It's easy to forget how vast and deep the ocean really is. About 60% of it is actually a cold and dark region known as the deep ocean, and it reaches down to 11,000 meters. Yet this remote zone is also one of the greatest habitats on Earth, harboring a huge diversity of life, from giant squids and goblin sharks to minuscule animals smaller than a millimeter. How do so many species thrive in this underwater world? Over the decades, intrepid scientists have ventured there to find out. Traveling down through the water column, pressure increases and light begins to wane. At 200 meters, photosynthesis stops and temperature decreases from surface temperatures by up to 20 degrees Celsius. By 1,000 meters, normal sunlight has disappeared altogether. Without light, life as we know it seems impossible. That's why in 1844, the naturalist Edward Forbes wrote his azoic theory, azoic meaning without animals. Forbes was sure that nothing could survive below 600 meters on account of the lack of light. Of course, the discovery of deep-sea species proved him wrong. What Forbes failed to take into account is something called marine snow, which sounds much nicer than it is. Marine snow is basically organic matter, things like particles of dead algae, plants, and animals, drifting down into the depths and acting as food for deep-sea animals. Largely thanks to that, abundant life forms exist in the darkness, adapting to a harsh reality where only the weird and wonderful can survive. Fish with cavernous mouths, spiky teeth jutting from their jaws, and lamp-like structures protruding from their heads. Like the anglerfish, which entices prey with its misleading glow. Several sea creatures have perfected this lightning technique known as bioluminescence, using it to lure prey, distract predators, or attract mates. Some creatures use it for camouflage. In parts of the water column where only faint blue light filters through, animals bioluminesce to match the glow. Predators or prey looking up from below are deceived by this camouflage, unable to see the creature's silhouette. Such otherworldly adaptations also arise from the need to locate and snatch up food before it drifts away. Some sea animals like jellyfish, comb jellies, and salps can migrate between depths, partially because their 90% water consistency allows them to withstand immense pressure. But they're the exception. Most deep-sea creatures are confined to a narrow range in the water column where nutrients are scarce, since the food drifting downwards from the surface rapidly sinks to the seafloor. Plunging all the way down, we find more exotic creatures. Some take on dwarfism, a trait that transforms them into miniature versions of animals we see closer to the surface. It's thought that reduced food availability causes this shrinkage. Only a tiny fraction of the food produced at the surface reaches the seafloor, so being small gives animals a low energy requirement and an adaptive advantage. And yet, the sea is also the land of giants. Here, gargantuan squids can reach 18 meters long. Isopods scuttle around the seafloor like enormous woodlice. There are long-limbed Japanese spider crabs and oarfish whose bodies stretch to 15 meters. This trait is known as gigantism, and it's something of a mystery. It's thought that high oxygen levels may drive extreme growth in some species, while the colder temperatures promote longer lifespans, giving animals the opportunity to grow massive. Many of these exotic sea beasts will never experience sunlight. Some will venture up through the water column to feed, and a few will actually break the waves, reminding us at the surface about the incredible survival skills of the ocean's deepest inhabitants. Humans still have an astounding 95% of the ocean left to explore, so those depths remain a great mystery. What other untold wonders lie far below, and which ones will we discover next?